Morning. In the previous video, we discussed the uh, right triangle similarity theorems, where we have a right triangle here, and then we have an altitude drawn to the hypotenuse. And to recall what we did, let's say we have this triangle here, and this is a right angle, and we draw perpendicular to the hypotenuse. So we have this one here perpendicular. Instead of naming segments, I will name the length of the segment. So this is A, let's say this is B, this is C, this is D, and this is the altitude H. Okay, from the theorem that we have already discussed, H here is the geometric mean of the length of the segments. It divides the hypotenuse. So C and D are the length of the segments. So we have here C times D. These are real numbers. And then this side A here is the geometric mean between the length of the segment nearer it, which is C, times what? The length of the hypotenuse. This is C plus D. Okay, and then D, similarly, will be the geometric mean of the length of the segment nearer it, which is D, and the whole hypotenuse. Okay, C plus D. So, this should not be difficult to memorize. H here, the altitude splits the whole hypotenuse here into two segments with length C and D. So that altitude length is the geometric mean of those segments. And then this leg here, A equals the length of the segment nearer it times the whole hypotenuse. So C times C plus D. And B here is the length, geometric mean of the length of the segment nearer it, which is D, and then the hypotenuse. Okay, let's apply that to some exercises. For example, we have this one. Uh, A here is an altitude to the hypotenuse. So that's actually now the geometric mean of the length of the segments in which it splits the hypotenuse. So 18, remember this is geometric mean, so product, okay? Again, instead of multiplying 18 and 3, you can just factor this out and find out if there are perfect square factors. So 9 times 2, and then we have 3 here. So we know that 9 is a perfect square, so I can take it out, so that becomes 3. And what is left inside will be 2 times 3, which is 6. So A here is 3 times the square root of 6. Okay? Similarly, how do we do number 2? That's the same thing. X here is the geometric mean of 10 and 15. 10 times 15. Again, instead of multiplying 10 and 15, you get the factors of 5, of 10, which is 5 and 2, and 15 is what? 5 and 3. And from there, you can get a perfect square in 5, so it can go out. That's a 5. And then we have square root of 6. That's the product of 2 and 3. So x is uh, 5 square root of 6. Okay. Let's get to number 3. Okay, let's have the equation for number 3. So y here is the geometric mean of the length of the segment nearer it, which is 5. Okay, times the length of the hypotenuse, which is 10 plus 5, which is 15. And you can simplify that. Okay, let's take a look at number 4. Number 4, we want to have an x. Now, what is the length of the segment nearer it? That is square root of 125. And what's the length of the whole hypotenuse? It will be square root of 125 plus square root of 5. Now, instead of simplifying this, the one inside, I can actually do distributive multiplication. If I multiply square root of 125 by itself, then I will get a 125. Okay? And if I multiply square root of 125 times square root of 5, you will get here square root of what? 625. But square root of 625 is 25. So this will now be plus 25. And we get here what? Square root of 150. Okay. Square root of 150 is actually this. 10 and 15 is 150. So this should give me also 5 square root of 6. Okay. Let's have number 9. Number 9 here, we want to get N, M, and P. So we can do first the geometric mean to the hypotenuse, which is the altitude 12. 12 equals square root of m times 18. And if I square this, I get 144 equals what? 18m. And m will now be what? 144 divided by 18. Okay, 144 divided by 18 is 8. Okay, so m now is equal to 8. If we know m already, we can get n. So what is n now? That will be what? The length of the segment error 8, which is 8, times the hypotenuse, which is 8 plus 18 is 26. Okay, again, instead of multiplying 8 times 26, I can factor this and I'll have a 4 and a 2. 26 is 13 and a 2. And notice that 2 and 2 will give me a 4, which is a perfect square, and this is also a perfect square. So, that's a 16, or that will give me 4. The square root of 16 is 4, and then what is left inside is 13. So, 4 square root of 13 is the value of n. What about p? P will give me square root of, what is the length of the segment nearer P? It is 18 times the whole hypotenuse, which is 26. Again, don't multiply 18 and 26. You factor 9 and 2. And then this is what? 13 and 2. Now this is a perfect square. 2 and 2 will give you perfect square. So that's a 4. So 9 times 4 is 36. The square root of that is 6. And what is left inside is 13. So P equals 6 square root of 13. Okay? So that's how you apply the theorem on the geometric mean, the similar triangles. Thank you and see you in the next video.